We are going to explore different facets of community capitals and then also explore their importance in enhancing and understanding various community well-beings in Iowa. Before I start, I think I need to introduce the team behind this project. So I am Solomon Eshen, a PhD student in applied maths, and I serve as a graduate fellow on this project. Up here with me, I have my hardworking undergraduate student, Manju Balayal, a software engineering major, Chris Le, a computer science major, and then joining us today is Lily Christensen, who is a statistics major. She is virtual. And we also have a supportive project lead in the person of Matthew Voss. And also we have two esteemed clients on this project, Bailey Hansen, who is a data analyst 3 at the Iowa State Extension and Outreach, and Jennifer Drinkwater, who is an associate professor in the Department of Arts and Visual Culture. So now, I know you might be wondering what community capitals are about. So before we delve into it, let me just give you a clue of what, or an idea of what we've tried to do or we are doing here. I know most of us here knows or perceive community to be about the towns and cities around us, but then community goes beyond that. They are basically categorized on 3 levels. That is, we have the geographic, that is, I know what is common to most of us here, and we have the, how do we call it? The identity level, which has got something to do with affiliations, and then the organizational level, which has got to do with our workplaces, schools, and other organizations as well. So when we say communities, these are the levels we are talking about, and not just the cities and towns around us. Now let's talk about capitals. So capitals in this context are defined as assets that are invested to generate new resources. And the main idea of DSPG is for the public good. So here I would define capitals to be assets that are invested to generate new resources for the public good. So joining these 2 definitions, we can define community capitals as community assets that are invested to generate new resources for the public good. So this is all what community capitals is about. Now, after defining community capitals, I need to also let you know the various categories we have. As it stands, there are 7 established community capitals, and our projects only focused on 4 due to time constraints. So we focused on the natural, the human, the social, we focused on the natural, the built, the social, and the cultural capitals. Now that we know what community capital is, why are we embarking on this journey? We need to ask ourselves, what do these capitals tell us or tell us about the nature of our communities? That's one question. The next question is, how well do these capitals tell us about the condition of our communities in relation to other capitals? So our project seems to address these questions by trying to carry out some exploratory data analysis together with correlation analysis and some modeling stuff to define or give some insight about what is happening in our communities. That aside, we've also collected or created a database for major events like natural disasters, school closures, flooding, employment shocks, and others. And all this information have been hosted on a Tableau dashboard. So now that I've explained or given you a clue of what we've done here, I would like to pass the mic to Manju to tell us more about what we've done. Thank you.
Thank you, Solomon, for the introduction. So moving on to our project methodology and our project timeline. So the initial week of DSPG, we primarily focused on trying to understand the different community capitals, looking at past research and previous measures that have been collected, so which in return helped us come up with our own measures. And coming up with measures can be difficult, but trying to find reliable data sources for them can be even more challenging. But we're excited to announce that we have collected 66 capital measures from 25 different data sources. And so after our data extraction and collection, we begin with our data pre-processing, where we transform these different data sets into meaningful format. And so this part of the project was quite tedious and quite challenging. As you can see, majority of our time actually went to this phase of the project. But after we finalized these data sets, we essentially merged them together in city level and county level data. And so our final product essentially is a data visualization dashboard with these three tabs. The exploration and maps tab is dedicated for visualizing the different measures and their values that we've collected and the distribution of these values on both city and county level maps. The bivariate analysis tab is to check the correlation between two different measures. And finally, the time series analysis is to visualize the different measures that we've collected from the American Community Survey data. So as for our tech stack, we primarily used Python and R, which are well-known languages for their data manipulation, data handling, and all the libraries and tools we used can be divided into these four categories. For data acquisition, we use Tidy Census to fetch our ACS data. For dealing with spatial data and fetching spatial data, we use Tigris and SF. For data pre-processing, we used Tidyverse, Pandas, and scikit-learn. And for visualizations, we use Leaflet, Matplotlib, and Seaborn. As for our final data dashboard, we built it using Tableau, which is a popular visualization software tool.
Okay, so I will talk about our data sources and measures. So as Montreal has mentioned, we have our 25 data sources and 66 measures. So we can include everything here. So we are just showing our 6 typical data sources. For example, the FBI crime reports, American Community Survey, which is abbreviated as ECS layer, Bureau of Economic Analysis, U.S. Department of Agriculture, Social Capital Atlas, and the Iowa Public Library Statistics. So from these sources, we collected some typical measures that you can see in bold right here. Yes. Because we have a lot of data sources, we can include everything in the pictures. So here I include here the link to the reference to all their phone data sources. But if time permits, I will show it at the end of our presentation. So moving on to the data processing, and as you know, this typically takes most of our time during the project. But just a brief reminder, the images and the Okay, so just a brief reminder, the images and the datasets that I will show below here are just for examples of different data processing steps. And the first thing I would need to talk about is the lack of reliable data, especially for city level data. And you know, most cities in Iowa had very few population, and this results in our significantly high margin of errors. And to this point, the only good solution was to collect county level data, and this also significantly cut down the margin of errors. And before the city level data, we have created an indicator for the users to know if that specific city has a low or high margin of error. So moving next to the data transformation. So as you know, our data came in different ranges and formats. So we needed to transform our data from raw formats into some kind of meaningful formats. And through different processes like their normalization, feature engineering, and merging a lot of tables to finalize the data sets. So here you can see here, these are the examples of our normalization process, their normalization process. So because we are clearly aware that there are huge differences in the population sizes among the cities and the counties. So that's why we decided to take the proportion with respect to the population size. And we also formulated some index to measure diversity. So which in this case, we use a Simpson index right here. And this ranges from 0 to 1. And I'm showing right here is just the example of a pre-processed data. And these 10 data sets are about active nursing homes from 2015 to 2024. And you can see here, we have like 10 data sets, and we need to finalize and make it into some meaningful formats that can be easily analyzed. So after transforming it and then merging all the tables together, we achieved a single data set, which has every single row corresponding to a provider and their corresponding features. That's per 10,000. And we also have the closing year and the opening date, which we will measure our event magnitude, which is the effect of the event on the community. We also need to work with spatial data. In this, we need to use some R packages such as Tigris and SF to gauge and extract the errors of lengths of and locations of different objects in our. So as you can see here, the data set is about the streams in our. And we are using the geometry column to calculate the length of the streams. And after that, we need to take to extract the intersection between the streams right here and their counties to see which specific counties the streams lie in. And with this, I use a SF package to extract the intersection. Among our measures, we also have some measures regarding the diversity of a community. But how exactly we measure the diversity? So in order to measure the diversity, we need to formulate some kind of index. And in our project, we use an index called Simpson index. So briefly speaking about the interpretation of the Simpson index, it is the chance of picking two random individuals that have different, that are from different groups, and in this context, from different race and beliefs, different beliefs. So this is our formula for the Simpson index. So for now, we can just understand the right-hand side term right here, the expression, is just the chance of two individuals coming from the same group. And when we take the 1 minus this term, it basically means the chance of two individuals coming from different groups. And I will explain this specifically in details later. So you can see here, the small n times small n minus 1 right here is just the number of pairs in a single group. And so when we take the sum of all of the small n times small n minus 1, it's just basically the number of pairs among the groups. And we have the cap n times cap n minus 1 right here. Is the number of pairs among all the groups. So when we take the divisions, it's just the chance of two individuals coming from the same group. So when we take the minus, we have the probability of two individuals coming from different groups. So this is an example. So for example, we have a group of people coming from 4 different origins. And this is the number of people. This is the number of people coming from that specific origin. And then we calculate the small n times small n minus 1. And we sum everything and we get 130. So then we apply those numbers into our Simpson index formula and we get this number. So this number means that there is a chance of 0.3421 to randomly select 2 individuals of different origins. So this also indicates that we have a low diversity in this group. Okay, so moving on to our challenges that we faced during the project. The first challenge I would say is about the learning new technologies because we are all new to R and its associated packages. So we need to spend a huge amount of time to learn and adapt with those technologies. We also need to learn Tableau for making creative, interactive and dashboard. And so for the data collection, this period, we also spent a huge amount of time to collect data, and we faced a lot of hurdles about making our data from a massive formats, such as on websites, to our expected formats. Our data also comes in some kind of special formats, such as JSON. And some data are already available online, and we need to use their services, the online services, to fetch the data, and the services are called APIs. And in a data science project, we also need to do some feature engineering. So feature engineering is a process for that we create a new feature from the existing features. So for example, from the available data about the layoff, the flooding, or the nursing home closure, we need to create a new feature called the event magnitude, which you can see right here. So this event magnitude measures the effect that a specific event has on the community. And the example about the Simpson index is also a type of feature engineering. So I will pass the mic to Moncho to talk about the time series.
Thank you, Chris. So the moment you guys been waiting for, the Tableau dashboard. So our Tableau dashboard is mainly divided into 4 main components, 3 of which are dedicated for the Community Capitals project and 1 for the Events Database project. So I'll actually get started with our events dashboard. So the filters for this dashboard is fairly simple. You start by selecting an event type that you're interested in. So any employment layoffs that have occurred or any natural disasters like tornadoes or floods, etc. And then you can select the years that you're interested in. And also there's a label for the count of events that have happened in that specific year. Finally, you have a filter for the county of interest. And so an example of a visualization from this dashboard is here we're visualizing the different facility closures that have occurred over the years. Facility closures like school closures and nursing home closures. As you can see, we have data that dates as early as 1946. And up until 2005, it's fairly consistent. And then suddenly it has this huge spike. That's mainly because the data that starts from 1946 to around 2005 is mainly the school closure data. And then we finally start getting data for the nursing home around 2005. That's why you see that spike, is because it's a combination of both of those data sets. Regardless, you can still see that there's been quite a bit of fluctuations and overall increase in the closures in the past decade or so. And here on the right, we have a map to just check the count distribution on a county level map. So our next dashboard is dedicated for the ACS, the American Community Survey Time Series Analysis. So ACS is just one of many data sources that we have. It's actually one of our primary sources, as 11 of 66 of our measures actually comes directly from ACS. But that's not the only reason why it gets its own dashboard. It's also a very convenient way and consistent way of retrieving or analyzing trends over the years, because it releases data every few years or so. We use the 5-year ACS data for years 2012, 2017, and 2022. And so the filters for this dashboard is also pretty straightforward. You begin by selecting the chart type. You have an option for bar chart and a line plot, or you may select both as well. Then you have a filter for the year, which only applies for the bar chart. And then next you can select the measure or city or county of your choice. Next you have the population slider. You can select the minimum population as well as the maximum. And this population slider is actually what's responsible for whatever gets populated in your city filter. For example, in this instance, we see that the minimum population is 64,000 and the maximum is 215. So these are the cities with that population range. And so this can be helpful for the user because we have so many cities. We have over 1,000 cities in Iowa, so we don't want to overwhelm the user with all the options. And finally, we have a label for the high margin of error, green for false and red for true. Usually it's the opposite, but we try to avoid the high margin of error. And so our first initial choice for this dashboard was to mainly have a line plot. And as you can see, we can see the fluctuations of the values over the years for any measure fairly easily. A bar chart can also do this, and some people may prefer a bar chart. But the main benefit of having a line plot is you can compare multiple places simultaneously. So here I have plotted more than 10 cities or so, and it still maintains that visual appeal. And another benefit of having a line plot is that you can read the label for the high margin of errors fairly easily as well. Here for this specific measure, we can see there's been some fluctuations. Some notable ones are Ames and Ankeny. They've had a decrease, whereas Urbandale and Iowa City have had an increase. But again, something to keep in mind when dealing with ACS data is the high margin of error. And we can see that for 2017 and 2022, Iowa City has been labeled as high margin of error. And so we also have an option for a bar chart, like I said, and a bar chart can be beneficial for comparing fewer places. Here I've only plotted 3 cities, Ames, Ankeny, and Des Moines. But if I were to add a few more places, for example, 5 or 6 more cities, then it can get a bit more chaotic and harder to read for the user. And so you can go through all these different dashboards and try to look for any interesting patterns or any interesting findings. For example, here on the left, we have this specific measure, proportion of long distance commute to work, which is actually from our ACS dashboard. And as you can see for Ankeny, the measure value has decreased quite a bit post 2017. And so this level of decrease is a bit unusual without any local job creation maybe or any economic development. But upon reviewing our events dashboard, we can see that Ankeny has actually had some economic development projects post 2017. And unfortunately, we don't have data for 2022, but according to the city of Ankeny, 2022 was a record high for Ankeny for investments in economic development projects for both residential and commercial. So all of these could be a huge factor as to why the commute distance has decreased. And so Lily will be taking over explaining the rest of the dashboard for us.
Yeah, so another tab that we have in our dashboard is called the Capitals Measure tab. So in this tab, you can choose if you want to look at a certain city or maybe a certain county, or you could decide to look at a certain population range for city and county level. Then once you do that, you can choose a certain measure that you want to look at. And then in the next picture, it shows an example. In the next picture, it shows an example of a city level map. And this map is showing the Simpson Index Race Diversity Measure. So the darker blue cities are the ones with the higher measure, and then the lighter blue color is showing that there's less or is a smaller measure value. And then those different circle sizes represents the city population. So those darker blue cities are Storm Lake, Conesville, Columbus Junction, and Denison. And all of these cities have a meat packing plant in them. And then with that plant, it can offer a employment opportunity for a more diverse workforce. And then in the next map, this one is a county level map that you can create. This one is showing the expected annual loss in dollars due to heat waves. So most of these counties are in the lighter blue range, which means that they have a smaller measure value. But there are a few counties that you can see that have that darker blue color. And the reason why we believe this could be is because these counties have larger urban areas, such as Scott County and maybe Des Moines County. And with those large urban areas, there is an intense heat wave due to the urban heat island effect. The type of population in a county could also maybe affect the expected annual loss. Um, whether a county might have more elderly people, maybe a lot of young children, maybe there are a lot of people with health conditions in a certain community. That could lead to people having to pay more medical bills, and maybe there's a higher need for healthcare services in a certain community, which could increase the expected annual loss in a community. Then, in the next picture, these are the filters for the bivariate analysis tab in our dashboard, which is called the analysis tab. And with this tab, you can choose whether you want to look at linear, quadratic, cubic, or exponential model, or you could choose that view section and you would be able to see all four. Now, if you're looking at the city level, then you will have to choose the population lower bound. It is set at 10,000 already. And then you can select two measures that you want to look at. They can either be in the same capital group or they could be in two separate capital groups. And once you have that done, you can decide to do a log transformation for the y-axis and x-axis, or you can do one at a time. And so then in the next picture, this is an example of a model, and it shows all four of those different models. This one is showing the relationship between the Simpson Index race diversity and the proportion of proficient English speakers. As you can see, there is a correlation, and with a more diverse community, there is a smaller amount of the proficient English speakers in a community. And a community that is more diverse could have maybe more native language instead of people speaking English. And then lastly, in the dashboard, we have a correlation tab. So in this tab, you can choose to look at certain capital that you might want to choose. So you could choose the row and column capitals, or you could decide to choose certain measures that you might want to look at and put those on the row and column measures, or the row and column of the correlation matrix. So then the next picture is an example of this is a picture of one example of a correlation that we found interesting. So this one shows that there is a high negative correlation between economic connectedness and the Simpson Index for Race Diversity. We believe that this is because of cultural and language barriers, and in a community with a higher diversity, it could make it harder for people to become friends and meet new people. Homophily social networks could also play a part in this because that means that there are more people connecting with people that are very similar to them instead of reaching out to different types of people. When there's a high economic connectedness in a community, it could also lead to having higher living costs. So people and families who might have a racially diverse background, that might have a lower income, it might lead them to having to move somewhere else because they can't afford those higher living costs, which could also lower the census index in a community. Now, the last picture shows a correlation between the economic connectedness and the number of total voters per 10K. We believe that an economically connected, or we believe that because economically connected people may have better access to education, it could lead to a better understanding of the politics around them, and they have a better access to information around them and being spread around them. Um, which then will lead to a greater awareness of elections and important decisions happening in their community. And with more people being informed and engaged and aware, it can create a higher level of people voting. But when there are more voters in a community, there could also be more civic engagement, such as civic organizations and political parties, which could increase an economic connectedness of a community. So our community capitals project is important because it can help decision makers decide where they want to allocate resources and invest in certain community capitals. It can show certain impacts that certain community capitals have and what the strengths and weaknesses are. This will in turn help enhance a community's overall well-being. Well, throughout this project, we have looked at 25 data sources and 66 capital measures. There is still so much that could be done for this project. For example, maybe incorporating additional data sources to help strengthen those measures that we have found, maybe find some new measures and help enrich those data sets. Then there could also be advanced modeling to help forecast future trends and help make predictions about community capitals. So throughout this program, our team has learned a lot about community capitals, and we would like to thank our graduate fellow Solomon, our project advisor Matt, our sponsors Bailey and Jennifer, and our program coordinator Haroon for the invaluable support and guidance throughout this program and project. The expertise and feedback that we have gotten these past 10 weeks have been very influential on what we were able to achieve with our goals and projects. So now I will pass it on to Chris, and he will show you a demo of what our dashboard looks like.
Our so I will continue to show you about our final deliverables right here. So you can see here, this is the about page, and there is the overall of our community capitals project, and also a little bit description about our dashboard. And here are the seven types of capitals and our logos. So first, we will go into the capital measures to see the spatial distribution of resources across the state of Iowa. Okay, so here you can see we have our measure filter. In this, we can select different measures to see the distribution of the measures, the resource. So in this case, we will see the distribution of Simpson index for race diversity. And so when you hover your mouse over the cities, you can see the population of the city, the measure name, and the measure value. In this case, the Simpson index. So you can see here, Storm Lake has a very high race diversity, which with a Simpson index of 0.76. And you can also see that This is the top cities with the very high Simpson index for race diversity, and this is the bottom cities. And this box plot shows the distributions of the Simpson index for race diversity, and each point is corresponding to a city. We also have the city filter right here so that you can highlight a specific city. So for example, I will highlight the Storm Lake. So you can see right here. And it's the city with the highest race diversity. It's right here in the box plot. And next, I will show you the ACS time series dashboard. Okay, so we have the bar chart and the line plot, and we have the chart selector right here. So I will select the bar chart. We also have the population slider right here. So if I will show everything again, and then I will show you the slider. So it will show the cities with the mean population of 86,000 people. And then we have a measure filter right here, where we can select our measure to see the distribution. So in this case, we will see the sorry. Okay, we select this one. And we also have the city filter where we can select the city. So for example, I will show the Icony city. So you can see here, in 2012 and 2017, Icony has a very high long distance commute to work, the proportion of long distance commute to work. But in 2022, the proportion, it significantly reduced to 0.01. And then we will go to the analysis and the correlation dashboard. So right here, we have a correlation matrix. So for example, this minus 0.347 means that we have this is the linear correlation between the cellular per 10,000 with the riches per acre. So we have the capital selector right here. So for example, I select the cultural capital. We also have the selector for the row. So for example, I select natural and social. So you can see here, this is the Simpson index for race diversity. And this is the economic connectedness. And we can see a very high negative correlation between the two measures. So we can visualize the correlation in the analysis dashboard. So we have the model selector. In this case, we will select the linear model. And we have the x-axis measure selector. So we will select the Simpson index for race diversity. And then we select the measure for the y-axis. which is the economic connectedness. I select the wrong one, sorry. So the x-axis, the measure for the x-axis is the Simpson index for race diversity. So you can see here very strong linear relationships. So when we hover your mouse over the model, you can see the R square is 0.47. And this indicates that about 48% of the variation in their economic connectedness can be explained by their model. And next, I will show you about the events timeline dashboard. So the map right here shows the number of events occurred in different counties. Sorry, the mouse is quite sensitive. Finally.
Sorry for this.
Okay, so these are time series 1 is showing the number of events occurred back to 1946 to 2024. So we also have the event selector right here. So for example, I just want to select some events. So for example, school closure. So you can see here, there are a lot of closures in this period, and then the number of closures reduces. And this table shows the details about our different events that has occurred throughout the period. Okay, so after that, I will show you about our documentation to the full sources that I have mentioned at the beginning. So this is the description of our project. After that, we have the structure of the documentation if you want to understand clearer, have a better understanding. And on the left-hand side right here, we have the different sources. So for example, I click on to the American Community Survey. So this is the brief description. And these are our measures, where are the sources, and how we calculate them. The proportion of commute. So that's the end of our presentation. Hope that everyone understands.